Welcome to Wiz Creek Workshop. My name is Yuchel. When you're working on a milling machine, you often need something to help support the material that you're machining. And it's called machinist jack. Well, today we're going to make one, but we're going to make a small version. So we'll call it mini machinist jack.
Except 1/8 your size.
Breathtaking. I shall call him
Mini jack. When we want a small one because it'll help us get stuff done in the milling vise that big jacks just can't.
cool.
I happen to have these drill blanks or drill rod, whatever they want to call it. This one is 3/4 inch. This is W1. You can harden it with and quench with water. I buy a lot of metal on eBay. You know, when I don't need a lot of it, you can find pretty darn good deals. Like this one, W1, I bought it through Zoro, Z-O-R-O, and 3-foot sections, pretty cheap. So, but people always ask, how accurate are these rods? So let's find out. This is my brand new micrometer. Look at that. 7/10. Eight-tenth. So we're going to start with the top piece, and this will be the threaded portion. It's going to be 7/16 by 20 fine thread, 3/4 inches long, 0.750. So we're going to take it down to about 0.4375 in diameter. Yeah, no, that doesn't look fun. Let's try a different insert. A little better, nice and blue. But let's see, what am I at? 910. Let's go up a little more, 1280. Yeah, this W1 sometimes just acts funny. Let's see if I can use my tailstock die holder. The drill rods are kind of slippery, so sometimes they slip on the jaws there. I've successfully threaded up to 1/2 inch, but after that it just becomes a little too much force to hold on the jaws there, and they'll start slipping. It helps if you have the die in there in correct direction. Start with the chamfered end. Let me swap that out. Now, at the very end, I come back with the die flipped backwards because the back side doesn't have that taper lead in, so it helps you get a little closer to the edge, but we're gonna have to relieve that anyway. Gonna relieve that shoulder there. A little bit of chamfer. Alright, we're gonna part this off. Finished dimension is gonna be 3/8. So we'll leave little meat for facing. Clean up, up, off, whatever. Hot! Little hot. Now let's make the body as Quinn Dunky aka Blondie Hack says, it's customary to start with the facing operation. And we'll do a light chamfer because we have raised the burr from the parting process. Now, since we're going to be tapping this, it is, what is a tap drill size? 0.3906. Change of plan. I'm going to part this to length first. 900. Better raise the tool a little bit. I have the body mounted on the chuck. Let's clean off the other side. So 9, 15 and a half, so we'll take 15 thou. Chamfer that edge a little bit just because we're here. Okay, we're gonna drill and tap all the way through. We'll drill up to it. So I'll start with something small. Randy, the brush you sent me, it's not looking very good. You may need to send me a couple more. What did I say? The tap drill was 3906. Close we got is 2564. Little lead-in chamfer. Little lube. Have it here. I'm going to screw that on and I'm going to clean off the face there. I like that. Now we want to clean off the back. I do want to recess so I can make additional pieces and stack it on if I need to make it longer. Now machining the recess for the next piece to stack onto, we don't have to do anything crazy. I'm just going to use a 1/2 inch end mill and hug it out. That'll just give a 1/8 inch wall around it and that should be pretty good. Okay, I stopped at 125. Now I'm not sure if that end mill was a regrind. Let's make a couple standoffs that the jack can sit on. How about one at 1/2 inch high and one at 3/4 inch high? This will be the top and we want the protrusion to be 1/100th of a thousand. The diameter we're looking for is 0.517. Just happens to be the recess on the bottom. So we got 154 to go. Turn the dial, set it 0. Alright, what should we make this one at? So we want 1/2 inch and 3/4 inch. Yeah, let's make this at 3/4. We'll leave a little on there for a little extra to clean off. Okay, I have the stock turned around. Let's clean up the bottom now. We're gonna machine it to length and we're gonna machine a little recess in the center. so that only the perimeter sits on the surface. Okay, we want it to be 3/4 of an inch, 0.750. We established the cut length right there. It is 775. We'll take 25 thousandths out of the length. Let's see how we did on the length. Ah. A thou under. We want to machine a small V groove right down the center. The way I mark that is I mounted it on this block, ER32 block, and using the height gauge on the surface plate, I identified the center and scribed a line right in the center. And I mounted on here at 45, and by turning the end mill by hand, I align that line with the tip of that end mill. Now, when it's time to feed, we want to move the table in the X direction this way and raise the knee at the same time, at the same amount before each pass. So let's say you move 50 thousandths this way, you want to raise the knee up 50 thousandths also before you make that pass, and that will essentially move this material at a 45-degree angle this way. Just a quick and dirty way to do it if you do not have a V-shaped end mill. I think that's pretty good. I don't want to go any deeper than that. Here it is. The groove is about 60 thousandths deep. Just doesn't need much. Just needs enough for a round piece to register on that, and it does that perfectly. And while I was at it, I made another one so you can have a matching set. Now you can be done right here if you want to, or you can heat treat them. I'm going to heat treat them because I do have a heat treating oven. Now if you don't have a heat treating oven, these are small enough where you can heat them up with a torch, and you'll be able to get a satisfactory result. But we'll go to the oven and show you what we got. This is Hot Shot 360. Sorry about the echo out here. It is made by Barzy Industrial, Stan Zinkowski. It plugs right into the 120 volt outlet, and it'll go up to 2000 degrees Fahrenheit. Pretty cool. Right now I got this program to ramp up to 1450 degrees Fahrenheit, and we'll soak it for 30 minutes. That's 30 minutes per inch, and close enough. And then we'll quench it into water, obviously, and then later we'll temper it by soaking it at 600 degrees Fahrenheit for 2 hours. That'll bring this down to about 55 Rockwell C hardness. Okay, the temperature reached 1450 Fahrenheit. We'll let it sit in for 30 minutes. You can see on the heat controller, the temperature controller, flashing light that indicates whether the heating element is being energized or not. This unit has a built-in alarm, over temp alarm, and it has a cooling fan behind the controller that turns on automatically regardless whether this heat is on or not. That's a double safety feature. Like I said, Barzi Industrial, I'll put a link in the description. Contact Stan. These things are awesome. Now, since I bought this, he came out with I can't remember the name of it. It's a double oven, so you can have one for heat treat and one for temper. And now he's also coming out with Hot Shot 1200. That is 1200 cubic inch. It's bigger and more awesomer, I guess. So, just wanted to show that to you. This whole unit pops out, and you can plug it into a USB port on your computer, and you can program all the temperature and time soak cycles, or you can just use it as a standalone through these buttons. It's pretty cool. The controller is a well-known brand by Novus. Okay, let's take these out. I have a metal bowl of water on the floor. First, we'll turn the heat enable off. Pretty hard. Should be between 60 and 65 Rockwell C. So we'll wait a little bit, let the oven cool off, and then we'll temper it. Okay, time to temper, putting it back in there at 600. We'll come back in a couple hours. When you heat treat, you have scale buildup on the surfaces unless you use specialized heat treating process, which, you know, I'm a home shop hobbyist. So I chucked it up and used emery cloth to clean up as much as I can, but I'm not happy with how, let me turn this light off maybe, how it turned out. I mean, just cosmetics, but we're gonna chuck it up here and take a ceramic insert and take a real light cut just to clean it up. This is a 3D printed indicator holder. Randy Richer showed it multiple times on his channel. Few thousandths, which is to be expected. Remember, when you heat treat, it expands and contracts. It's not going to stay true. I'm okay with that. These are Sandvik ceramic inserts. There's the number. You can find these on eBay pretty cheap if you keep an eye open. We're gonna turn it at 1280 RPM. Now I backed out the carriage, left the cross slide in place, and we'll flip it around. Literally taking maybe 1.5 thou. You'll see a little bit of a line there, but I really don't feel anything. We'll clean up the ends. I forgot to clean up the other end, so we'll flip it around again. Beautiful. I did the same thing to the top pieces as well. To clean out the grooves, I'm using some sharpening stones, or polishing stones I should say, that I got at a sale. A mold maker was retiring and he had a tub of polishing stones, so I ended up just buying them all. So I couldn't tell you exactly what they are, but you may be able to find some more info on the internet. It removes the heat treating scale and discoloration pretty quick. Now, I'm not going to get them all, but it's nice to get most of it off. Well, here they are. They turned out pretty good. Matching pair, and 3/4 inch and a 1/2 inch step. Now, if you need to go higher than that, you can always use a 1-2-3 block in combination with any of these. So let's take a quick look at how you may want to use this on your milling machine. Earlier you saw me use this ER collet block. Sometimes you have to hold it on its side like this while holding a material so you can machine flat spots. Well, let me move this over here. When you clamp, there's nothing supporting on this side of the milling vise, and it's not good to apply all that force because it could tweak this jaw and it would hurt your accuracy. So this mini machinist jack, you can put it in there on the other side and you clamp. It ensures that the jaw doesn't tweak too much. That's one use for it. The other, there you go, quick reflexes. Let's say you are holding, I know this is a cardboard, but pretend this is a material that you want to put in your vise and hold. And you put a pair of parallels on each side and hold it. But let's say you want to drill and machine holes on this side. Well, right here, because of the angle, there's nothing supporting it. You can put one of these underneath it to provide the support. Let's say you have a long piece and you have to do some machining on outer ends of that long piece. You can put a 1-2-3 block and one of these jacks underneath it, and ensures that this doesn't deflect. So those are some examples of how these can be used. That's why I made these small. Typical machinist jacks that are intended to be used on the table are probably twice bigger than these. But then it's not really easy to use inside your milling vise. So you know what they say, you work on a project and in the process you identify needs for additional tooling, and these are results of some of the previous projects that I was working on. And you can increase the height 1/2 inch and 3/4 inch. I didn't feel the need to make any more than that because, again, you can use 1-3 blocks, get as high as you need to go. You just need to make sure that, be mindful that this is only 3/4 of an inch in diameter, so go up too high, it may not be too stable. For the sake of full transparency, I want to share with you what happened while I was heat treating these parts earlier. These were the original parts that I had made, but during the quenching process, you can see cracks had developed right there, and then it continues on right there. That one's interesting because cracks started You would expect the crack to start at a stress point, typically a V notch like that. Exactly where this one started. Oh, this one is the one that goes straight and then offsets and goes all the way there. That one, I don't have my, oh, right there. And interestingly enough, this piece as well. Crack goes right there, and then it goes along the circumference. And this is what happens because when I don't pay attention, the quenching, these are W1 steel, so you're supposed to quench in water. And I didn't pay attention. I didn't even think about the temperature of the water. It was a little chilly, so it was probably around 40 degrees Fahrenheit, the water was. And it just proved to be too drastic, too much of a shock. And these just cracked. So, you know, obviously I made new ones. And when it was time to quench these, I heat the water. So I did a little more research, I guess, between the parts, and they recommend that sometimes, depending on the application, bring the temperature up, up on the water anywhere from like 110 degrees Fahrenheit to 200 degrees. Anyway, I didn't measure it, but I boiled the water and let it cool off for a bit. So I don't know, maybe 160, 170 degrees Fahrenheit. And I quenched in that, and that was just enough to ensure that these didn't crack. Now, you do sacrifice some hardness when you prolong the quenching process, but these are pretty hard still. I did temper at 400 degrees for 2 hours. It should be around Rockwell C50. So still where I want it for my application. But I thought those cracks and, you know, it was pretty interesting. So I thought I'd share with you so you know what happened. You know what they say, all good things must come to an end. I never understood that because if it's good, why must it end? Well, I know this video has to end because I have to go and edit it and put it on YouTube for you guys. Well, the project was fun. My heart kind of broke when those parts cracked, but you know what? That's the way life is. So you just make a new one and move on, you know? You can't cry over, say, spilled milk, but in this case, crack jack? I don't know. But anyway, I appreciate you guys watching. Please comment and like and subscribe. I'll see you next time. And we're gonna make a small one. I call it mini machinist. Blah 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 blah. When you're working on a milling machine, you often cut.